Hi there, I'm Kitty Colding, host of the new IPTV show Data Geniuses, where we talk to innovators across the spectrum in the wide world of data. Our guest today is Jack Levin, the founder and CEO of Inventify, a company that creates cloud-based software solutions. And in particular, we're talking today about his product called ImageIser, which helps companies solve their image manipulation problems, particularly when the image data they possess is at a truly epic scale. Jack, thanks for coming. We're thrilled to have you here on the Data Geniuses show and to have you live and in person.
Thank you for having me.
Before we dive in and I start peppering you with questions, I thought maybe I'd set the stage and talk a little bit about your background quickly, if you don't mind.
Sure.
As I understand it, you were employee number 21 at Google, stayed there about 6 years, left post-IPO when the company was about 6,500 employees. Went on to found a company called ImageShack, which at the time was the largest image storage company of its time, and which notably got funded by Sequoia the same day that you pitched to them, which I think is a fabulous story that I'd love to hear sometime.
Yeah.
And then after some twists and turns, created ImageIser, which I know was sort of an evolution. And your focus really is on with big e-commerce players who have a very serious and sort of substantive need for image management and optimization services.
Yeah, and image delivery.
And image delivery, great. Okay, did I miss anything important?
No, just a quick note. So I did stay at Google for about 6 years. I left about a year after the IPO.
Mm-hmm.
Essentially decided to do my own thing, kind of like get into the grind of things.
Mm.
I was in management at Google, and I really kind of wanted to go back to my roots and do more of the hacking, so to speak, and build products essentially.
Mm-hmm.
So that was the thought.
Cool.
I probably would have stayed at Google forever because it's a great, fabulous company. I really enjoyed being there, and I learned a lot being there like so early and not knowing Google would become that huge of a player.
Yeah, yeah.
So.
Do you keep ties with them? Are they constantly checking in on all the wonderful things you're doing?
I mean, I run in every once in a while into Larry and Sergey, and we're chat a little bit. Just recently, we've been at the company ski trip, and we ran into Larry Page. He was skiing there with his sons. So
Cool.
we talked for a little bit, and then part ways.
Yeah.
So they do remember. I mean, they were the two guys that hired me literally off the Stanford's campus.
It's impressive. Okay, so let's talk a little bit about ImageIser. What made you create this product and focus it on image manipulation, especially with this question of scale?
Yeah, so I was always attracted at solving big problems and huge problems, and Google really gave me an opportunity to learn about scale. So what I wanted to do with my startup is to apply what I learned to essentially designing a product that can do a lot of massive things. And one of those things was delivering proper sized images quickly to end users and to consumers. And that was actually not a trivial task. So imagine 2 million to 3 million image files loading into your site daily, and then you need to create thumbnails. Seems like a trivial task. In reality, it actually took 10 servers for each single storage server to do just that. So most of our costs was to essentially running image optimization and image conversion for ImageShack. Ultimately, we decided that will not scale because we just kept receiving more and more images from the end user site, was more and more popular. So what we decided to do is we decided to optimize images on the way out to the user and not touch the image during the upload.
Instead of taking every image that comes in.
Yeah, so taking and optimizing every image that comes in, even without knowing whether the image is going to be served to the web, was an inefficient way to do this. It was kind of like using weapons of mass destruction when it comes to your CPU CPU type.
Right.
So we decided to have a more surgical approach and to optimize only images that are being received by users at the time of the query, and then cache those images so they don't even become files and they don't land on storage servers, they just go into cache. So that was the idea. that ran really well for a while, and then again ImageIser became even more popular. There were more queries coming in, and even those servers were being taxed so hard that it became relatively impractical.
So what year was this approximately?
That was, I believe, 2011, 2012.
Okay.
Something like that. And then I think the catalyst for ImageIser as a product was really kind of like a situation where I had a friend at Pinterest, and that friend worked in infrastructure as well, and he basically reached out and said, hey, you guys know images, and we're at Pinterest do images. We do a lot of images. What can you tell me about optimizing images for our pinboards? And I said, hey, we have this internal project that's kind of like optimizing images for ImageCheck, and maybe we can use it for Pinterest as well. So after a few meetings at Pinterest, we gathered the requirements, and we realized that we need to make ImageIser about 100 times faster to work at Pinterest. And we took about, I would say, 6 to 9 months to get the research done to optimize what we thought already was pretty great service, but it became even faster. And then we did a POC for Pinterest, and they ran about 1 to 2% of their traffic through ImageIser. At which point, it kind of made sense to think that if Pinterest needed that as a product, then clearly there are other sites and other companies out there who would benefit from this technology.
Yeah. Wow. And so then you transitioned from ImageCheck and went full force and created ImageIser as sort of the lead product for this image manipulation.
Yes, so I really wanted to explore the B2B aspect of the business. So for years I was doing B2C, or business to consumer, and the main revenue was subscriptions and advertising. And I really wanted to see what can we do in the enterprise space. Can we really help large companies like Nordstrom, Macy's, Home Depot to present their media and their images in the best possible way for their users of their site.
Okay. And so I think one of the things that would be super interesting is to talk a little bit about the scale, about the sheer massiveness of the kinds of projects that you work on for your clients. Everybody knows that images are heavy duty. You know, they take up a lot of space. But if you could put some perspective on that for us, for the kinds of clients you work with.
Sure. So without naming any names, we have a client that has about 100 petabytes of data, which is 100,000 terabytes of data, which is a lot of data. That number in itself is small compared to, let's say, about 40 billion images that they have, or billion files. And I'm talking about the original files actually loaded by their users into their site.
So the 100 petabytes is about how many images?
It's about 40 billion images. So,
okay.
So their task for image manipulation and optimization is enormous. It's very difficult to work with the massivity of this data. It's really big data right there. So it's important to have best of the breed image rendering technology to actually be able to get images out to their end users that use their site.
Okay, great. And so prior to you bringing forward all these capabilities with ImageIser, what were companies like this doing? How were they handling this issue?
So there's multiple ways to deal with image optimization and image resizing. And when I say image optimization and resizing, we really talk about responsive images. Now, what I mean to say is that I think everybody's familiar with responsive web design. That is where, based on your browser resolution or your monitor resolution or browser window width, your page layout gets scaled appropriately for you to have the best experience. Now, unfortunately, everyone has a slightly different browser, so you have multitude of layouts available, but you don't have multitude of images available to be perfectly aligned with your responsive web design. So what we're doing is we're approaching responsive web design by integrating it with what we call responsive images. So responsive web design...
Is this your innovation, responsive images? Ish?
I would say there's multiple projects that address the same thing. We address it in a particular way running image optimization on the fly under 100 milliseconds per conversion, so that you do not wait for rendering. So that is where our innovation is, in the speed of creation of the proper image format.
Gotcha.
That is where we're, in terms of the concept itself, in kind of no-brainer. So your original question was how were companies doing it before? So I would say that if I ran a medium-sized company, I would simply take my image library of, let's say, 100,000 images, and I would run a script to create 5 or 6 or 7 or maybe 10 different image versions of different sizes, and I would put them in different folders. So I would do that, and then I would design the web-facing product with responsive web design to tap into the folders or directories where images are to pull the proper images. The problem with this approach is that it works for this particular task. Now, as soon as you start evolving your website, all of a sudden you have more images and different landing pages. You have needs for different sizes that simply do not yet exist. So you end up redoing this whole process of creating static images
over and over
again. So it works while your image database or image number of files is small enough, and ultimately it becomes unwieldy and impractical. So our approach is different in the sense that we're basically saying, look, you have your images, you have your original file formats, keep them as they are, but let the software do the manipulation and optimization at the time of image delivery. Therefore, negating the need of creating any sort of static content.
Yeah, and so much of an apparatus behind the scenes you've been able to essentially eliminate from their workflow, from their process.
Yeah, because once you launch ImageIser and integrate it as part of your stack, the software does this one thing and one thing only. It produces images for the web queries. You don't have the situation where you're creating static images and somewhere halfway something breaks or not all images are created. You don't have to do any sort of verification. It simply works as it needs to work because it only does image optimization for what it needs to do.
I can imagine the reaction of your clients when you have the opportunity to explain to them how transformative this software really can be for this enormous and incredibly critical problem. E-commerce players, it's so critical to get the images right. So is this really an epiphany for them? Are they sort of blown away when they talk to you about this?
Yes and no. So when talking to large companies, we have to realize that they have a lot of infrastructure in place, and they like their way because they have invested in their way. But there are a lot of companies that are big enough, that are very innovative. They think that image manipulation is not what their business is all about. It's about sales, it's about user retention, it's about user experience, right? So why not let the technology do what it does best, and leave image manipulation to a company like ours that produces software that can turn or be a turnkey solution for what you need, rather than spending a year or two developing something that's already been done.
And they can focus on conversion and
or bringing more innovative products to their new landing page formats, or tapping into more of a mobile experience. So, and let us help them bringing in the best quality images to their end consumers.
Yeah, great. So one of the things that I've learned about with regard to ImageIser is you are also at the point of announcing a really amazing sort of step forward and evolution of the business involving blockchain to take on even larger challenges. So can you tell us a little bit about that?
Sure. So until essentially this year, ImageIser was a component of the media delivery stack. But we also have clients that require image conversion that is not necessarily for web consumption. They simply want to compress their images. So if you imagine having a client that has 40 billion images, running, let's say, 1,000 to 2,000 to 5,000 servers to do this sort of conversion would take months to finish. So we thought, given those requirements, why not tap into the blockchain miner community that is tired of mining and have those miners actually do image manipulation driven by blockchain as a fulfillment center for both task production as well as the accounting and payment for the tasks being done. So not in so many words, I would call it Airbnb for compute or Airbnb for your CPU. It's where you carry your notepad or notebook and you're at the coffee shop and you're browsing or you're checking your email or playing with Facebook or whatnot, and you have spare CPU capacity. You could be renting out that sort of CPU capacity to a company that wants to compress their data. So that's where the blockchain comes in, because it allows the kind of like this brokerage between the task creators or owners of the task and the actual workers. And they don't have to worry about who is who, because everything is done anonymously and verified by the system itself.
It seems like such a natural, but what made you start thinking about incorporating blockchain? I mean,
so I have history with blockchain actually. I often go back to Google for lunch with my buddies, right? The people that worked on my team, and we talk about things. And at some point, about 2010, 2011, somebody was like saying Bitcoin this, Bitcoin that, and laughing about it. And I thought it would be cool to investigate what this whole technology is all about. So I was involved with blockchain and Bitcoin since 2011. Mined some Bitcoins, myself, just to see how it works, using our spare data center capacity. And then later I got involved with Ethereum, which was very interesting to me because it allowed the exposure of an API into the Ethereum blockchain to actually develop smart contracts that can do things for you, backed by the peer-to-peer network. So which was kind of a novel, very interesting idea, and I thought immediately, can we take our ImageIser engine and have the blockchain be the driver behind the distributive component of the blockchain,
right.
So that we can actually take the data, send it to ImageIser that is controlled by blockchain.
Right.
So rather than running ImageIser itself on a server somewhere, it would be running in a Docker container everywhere. Right. Whoever wants to run and participate in this sort of useful task, not just mining of crypto.
Right. And so, when are you ready to bring that to market? When does that make its appearance?
So we're at the demo stage right now. I would say within the next few quarters, we'll probably be able to have something that can accept tasks from multitude of clients and allow the workers to come in and receive the client code to actually run this sort of mining.
And in terms of the workers who would be handling these processes through your system, what do these people look like? Are these sort of regular humans walking around, or are these sort of super geniuses or existing crypto miners that are just way into this whole thing with kick-ass computers and tons of CPU?
So I would say just average people who have spare CPU cycles, have a browser, have interest in potentially making money by doing something useful for a client out there that's giving you tasks. So not in so many words, this is not really novel technology. So we had SETI at home and we had folding at home, where the computing runs as your screensaver, and that can run on your laptop or it can run at home while you're not at home, and so on and so forth. This is a little different because you actually get paid for the tasks that you do, and you have very discrete tasks that you're given.
Yes. And how will you recruit these workers? Or do you imagine it won't be very difficult?
If you want success and perfection, there's effort that needs to be applied pretty much to anything. I mean, there's no such thing as not a difficult thing. If it's not difficult, it's probably maybe not even worth doing. But anyway, so I would say definitely marketing and sales need to be involved. We're thinking about doing some tests on college campuses, gather some data, do some A/B testing, kind of really learn from the sort of process, and then essentially decide on the proper path to push this technology forward and to introduce the capabilities to the population.
And have you talked about this? Have you sort of broached this new capability with any of your existing clients? Have you done some anecdotal testing in that way?
Yeah. So we have a client that's using ImageIser today on premise. So they're running ImageIser locally in their own data center. They also have a lot of images that they want to compress. They're interested in exploring blockchain technology, both for kind of like their local enterprise, kind of distributed but inside their own data center, as well as outsourcing this task towards workers out there that they wouldn't even need to know who they are. So it's kind of like basically saying, here's the compute cloud out there, like I would say Google, Microsoft, Amazon, or AWS, but here's a ton of spare capacity that's out there that can also be kind of like a co-creator of this fog computing or cloud computing that does interesting tasks with the data. And the data manipulation or any sort of compute application doesn't need to be images. It could be statistical analysis, data compression, restructuring, search, DNA matching. I mean, you name it. It could be anything. I mean, we're talking about compute here. Compute can be applied to many different disciplines.
Right.
So, like human genome, for example. Let's say that you have a slice of a DNA text, Gattaca text, and you want to match it to genes, and you have a ton of that data. So how would you do it? Well, it happens to be a very distributed task. You can actually split it into pieces, give it to 1,000 people, and in about an hour they will produce gene maps to the data that you're trying to map.
And so could you give us again some comparison perspective on how you've been handling massive amounts of images and image data through ImageIser, and then the distributed blockchain-enabled version in terms of speed and cost? What does that look like for your client?
So, if you were to do your own image conversion and image manipulation and creation of static assets, first of all, you pay for storage, extra storage. That's one. But even if you did not pay for storage, that actually means that you have a team that is responsible for asset production and creation. So a lot of people say, hey, we built a bunch of scripts, they kind of work. But I always ask, okay, how do you know that right here, right now, at this moment, your program or your script actually does what it's supposed to do? And the answer might be, well, it just works, we know it. But in reality, there's a team behind it that has pagers and on pager duty connected to a monitoring system that will tell them that something is broken or not broken or they're out of capacity or what have you. Now, if any sort of thing happens, then they need to rally the troops and fix the problem or redesign the whole thing. Now, that costs money. So I would say that this is a hidden cost. It's not something that it's not the CapEx, it's OpEx that really kills you.
Yes.
So 3 engineers in Silicon Valley could easily be $400,000 per year, right? Which is a fraction of the cost of what ImageIser would cost you. So ImageIser would cost you probably under $100,000 a year for a relatively large website to do image manipulation. So to do the same thing and do it faster, better, cheaper.
Right. And are you naming the blockchain-enabled version of ImageIser something different? Does it have sort of a different moniker?
We just call it blockchain distributed compute for now. So I wouldn't nail image manipulation task to it very hard, just because I really want to introduce this capability as general purpose compute.
I see.
But
not solely for image manipulation.
Not solely for image manipulation. It just so happens that we have clients that have the tasks that they want to do, and their requirements fit within the blockchain capability.
And so that's one of the questions I also wanted to ask is, ImageIser is a product, but Inventify is obviously the company. Are there other products like that you are conceptualizing or in operation?
So we have another pilot blockchain project that involves essentially using Ethereum blockchain to create a user directory that maps your public information, like your phone number and your email address, to your crypto wallet address. So like, for example, let's say that you want you want to send me some money, or I want to send some money back to you for whatever, like the lunch we had. Now, you don't have that many options in telling me what your wallet address is. It's really a large string of numbers. You would possibly copy and paste that address and send it to me in my, to my email address, and then I would copy and paste that into my wallet and send you some funds. So what we're trying to achieve, we're trying to basically do away with that lengthy process and say, as long as you know the person's email address, you can send them funds. So the goal here is to associate the email address with your crypto wallet address and launch it on Ethereum, where Ethereum is a peer-to-peer blockchain-backed distributed database that allows you to do this sort of lookup, which is really awesome because even if we decide to close this project down, the records will be maintained by blockchain. So we're not at the gate of requiring people to go through us to actually read the records.
And does that have utility for sort of broader ID verification purposes beyond, passing of currency? But
absolutely. So think of it as connecting pieces of data together and being backed up by blockchain. Like for example, iPhone has a thumb scanner. We can connect biometrics data with some other interesting data. Again, it could be your wallet data, or it could be something else, like your potentially credit score, or whether you had any accidents. So you could potentially use this technology to go and rent yourself a car, and just by literally sending a signal to your phone and running a lookup into this blockchain database, you will allow the rental company to get the authenticated record from yourself. So in this particular case, we would act as a kind of like a digital notary, where we verify that your thumbnail is really yours, and then the data that you're presenting is really yours as well. But then we just push the data to the blockchain and it stays there.
It has so many implications. My mind jumps to an area that I've spent a lot of time in recently around ad fraud, and thinking about who's actually seeing ads, who's actually being served ads, and the whole issue of privacy, because the business that I've spent a lot of time in is about sort of controlling your personal data. And it just sounds like a fascinating step forward for everybody, really, in that context.
Yeah, it's I think it's very exciting, especially the fact that you don't need to run the database yourself, or you don't need to make people worry that you as a company may manipulate the data to your own advantage.
Yes.
A smart contract exists as a public entity out there, and then it's populated with the data, and the data remains there immutable, essentially.
Yes.
So, and it runs by the peer-to-peer nodes itself.
It's a fascinating thought. Okay, well, thank you so much. Really appreciate it. Thanks for joining us, and thank you for tuning into this episode of Data Geniuses.